you enjoy, relax?
Yep. And you?
Short, short answer, everything okay. Uh, Today we should go on and start doing this numerical methods part. Uh, all about statistics is basically done already. I think you have some reports still to return. Uh, so the correlation and regression, and after that, when you get the feedback for this one, when the final report, and from the learning diary, I noticed that hypothesis tests wasn't even open, so if I remember correctly, you have time till next week Friday, and the correlation regression part 1 week after that. So after that, this statistics part is basically done. It may be that we do something still with the statistics, but it's just for to help the numerical part. The numerical methods, now what you return to me is basically easier and different, so that you don't need to write so much. Because these are numerical methods, algorithms and programming is the main part. So what you return to me is the file which I can run. Basically, it's even done with MATLAB or with the Excel. I basically could accept also the MATCAD, but the problem is that this program in Moodle doesn't recognize the MATCAD file, so that's why it's not possible. First of all, how many of you, just put the hands up, if you are familiar with MATLAB?
MATLAB, not MathCAD. Like
MATLAB, yes, not CAD, lab, like a laboratory. Okay, how many of you is familiar with MATCAD? So you have used it also with Heikki in our courses.
yeah, we had some experience with Heikki, and also we used it during a couple of other courses. So
Okay, good.
we're quite proficient.
Yeah. How many of you have used it during this spring or at the end of last year? Okay, so you are familiar with this new version of it because it's a little bit different than the other ones. I have some problems in understanding what happens there, but the form, how to use it is basically the same. All right, Excel is probably known by each of you. How good are you using Excel? Can you do use the functions and so on well?
I think some easy function, not
Okay,
too complicated.
all right. But you have used it at least with Petteri, but is there some other teachers also who use it?
I guess no.
All right. The last question, only those who have studied matrices earlier raise their hands now. so some of you not all. Because today the main idea is that we go through the matrices, the basic ideas of them, and do some exercises. If you have studied the matrices before, there is nothing new for you. So basically what you can do is to concentrate on the first part of the matrices exercises. So for this week there is nothing you need to return to me. You do them only to help yourself. Exercises here are done in 3 or 4 parts. So here are the exercises, and what you should do first is to solve all of them with the paper and pen. And when you have done that, when you solve them with the MathCAD and today with the Excel, if we have time, then I get you familiar with the MATLAB. But do all of them, and I said do all of them with the MathCAD and with the Excel, because when you do them with paper and pen, you will find out that some of these exercises are the ones where the solution cannot be found, but the error mistake given by the program is the most useful information what you can get. Because today we are practicing with these easy cases. You have matrices given and so on. So they don't give you anything more with error mistakes. But when you are programming the real life situation, when you form the matrices and you may think them a little bit differently, then these error mistakes are important. They tell you where you have probably misthought the idea or miswritten something, or what you didn't even think about at all. So that's why do all the exercises with MathCAD, MATLAB and Excel. We use a time for the MATLAB, but if you can do all these exercises with MathCAD and Excel today, that is already a good thing. Is there anything you want to ask at this point before this? Yeah?
Yeah, so we need to complete this exercise both using MathCAD and also Excel, right?
Yes, today, yeah.
Today.
Yeah, and if we have time, we try to use also the MATLAB, but it may be that we do it next time so we can concentrate on that part also. And about when you return the program to me in this exercises concerning the numerical methods, you have to have some kind of analyzing part written inside the program. So not a separate file, only some few sentences, so I know that you understand what the results actually mean. What is your idea? What is the matrix?
Two-dimensional array with numbers.
That was quite mathematical. I would say it's just a table of numbers. Basically, if you think any kind of table, you could have information about, for example, what we had in statistics, but you had the data, you had the table, there was the columns, there was the values of one particular variable, and when you had the rows which were some observations. When we talk about the matrix, all information for the variables and for the observation, it's just numerical. So you have numbers there. This matrix here, for example, this A, it doesn't mean anything. It is just a table of numbers, just because it's not in connection with any practical case. But if we talk about, for example, finite element methods, we have the matrices and they all have some kind of connection to the real life case. How these beams and supports what we have there are connected. When we are acting with the matrices, the size of a matrix is important, and the size is always given so that it's in the form rows times columns. It's not solved, or for these are the numbers. So for example here it's given 3 times 2. We have 3 rows, we have 2 columns. And this is important because the size of a matrix tells basically can you do any calculation with other matrices, for example. Today we talk about, for example, addition and subtraction, and they can be done only if the matrices are exactly the same size. So if there is 1 row or 1 column more, it cannot be solved. So for that reason, it is very important to know what is the size of a matrix. Usually matrices are given with the uppercase letters and with as a bold one. And with this kind of material, when it's computer written, if the bold one is easy to see, but if it would be handwritten, it wouldn't be so easy. So basically you can use this a line like for the vectors to separate the matrices from just normal uppercase letters if you want. When you talk about the matrix, it's even a combination of this kind of vectors. So all columns basically are one vector, or every row is a one vector. So all what you can do with the vectors can also be done with the matrices. We deal already on this course with several programs, and as you know already by this point, recognizing how the program is actually acting, you have to check the help and other material. So what is done in our program may not be working in the other one at all. So when we are handwriting, we usually keep the name of the matrix, and if we just want to get one element from there, we give this sub-indices so that the first number refers to the row and the second number refers to the column. So for example, in this example, the row 2, column 1, you can see that the value there is 4. When you are acting, for example, with the MATLAB, it would be given like this form, and you would get the 4. And then there is a mistake. Basically, if we talk about the MATCAD, this is not working like you believe. Actually, this one would refer to the element 7 in MATCAD. In every other program what I have met, the origin for the matrices is 1, 1, but in MATCAD it is 0, 0. So the number 4 would be 0, 1, 0 if it would be written here. But there are some programs which use these square brackets and with this kind of form. I have heard and I have been told that it is able to change this origin in MATCAD, so it starts from 1, 1, but for some reason I haven't done it correctly. So for me it has changed only for first one to start from 1 and the other one starts from 0. If you can do it so that it acts like usually we are acting with this, then just give the information to all of us. Don't hesitate to do it. We have different kind of matrices. The square matrix is easy one, the number of rows and the columns is exactly the same. So basically this is the base information about the matrices. Here we have something more, so please remember two matrices are said to be exactly the same if all corresponding elements are exactly the same. So if you solve the value and it is same, then they are the same, but it has to be with all elements. We can put the numbers in the order, but for the matrices, this order doesn't exist. So we cannot say that this matrix has bigger value than the other one. There is no order at all. Diagonal element is something what you need. It means that the row and the column index is exactly the same. And identity matrix is something what you need all the time. So when you have the identity matrix, all other values are zeros except on the diagonal the only value is 1. So here all the values are ones, everywhere else they are zeros. If all elements are zeros, then it's called zero matrix. The meaning of identity matrix and zero matrix is exactly the same as with the numbers. If you multiply with the identity matrix, you get exactly the original matrix. If you add zero matrix, you get exactly the original matrix. So there is no change in that kind of thinking, but of course how to get this may be a little bit different kind of cases. We have upper triangular and lower triangular matrices. We don't basically need these during this course, but these are important when you have a system of equation where you have several variables, and I don't talk about 3 or 4 variables. I talk about, for example, like in the FEM, in very easy case, the number of the size of a matrix is already 10 times 10 or 16 times 16. And if you should solve values for all unknowns, like in the system of equations, and the size of a matrix is hundreds times hundreds, using the normal Gaussian elimination method would take too long in many cases. So there are more sophisticated questions how to do them, and some they use upper and lower triangular matrices. If you need them, you can find them from numerical method books, but I think in these topics what we are dealing during this course, you don't need them. The only difference is that in the upper triangular, all non-zero values are above the diagonal. It doesn't mean that none of them cannot be zero. Of course, there can also be values of zero, but below the diagonal, only accepted value is zero. And in lowercase, vice versa. So here are the matrices. In some cases, the matrix may be in the form that there are only some values which are not equal to zero, and in that case we call it as sparse. And just think about when you have this kind of case, using a normal calculation method would be time consuming. No, not even my talk is working today. But anyway, there are the methods how to use these. And here once again, they have to be a big one. So there's at least hundreds of rows and columns before there is a sense of using these methods. Because for the smaller ones, the computers nowadays are working nicely and fast, so it doesn't matter for you. But I don't know what you're doing in future for your work. Do you need them? So this is just extra info for these cases. Do you have anything to ask so far? If not, today what we go through only is this part of the operations. We'll talk about the multiplication determinants and inverse matrices next time. But when we have gone this through, what you do is that you solve all these exercises of the first case with paper and pen. Or let's say at least exercise number 1. And then we check how to do them with the MathCAD and how to do them with the Excel. Transpose is a very important part, but it's also one of the easiest things what you can do for the matrices. It is just changing the rows and columns correspondingly. So just think about that you form the table where you have some kind of information, for example, the days and the temperatures, day 1, and what is the temperature, day 2, what is the temperature, with this thermometer and a second row for a second thermometer. If your friend would have done this one, he or she could have rows and columns in like vice versa. So for these cases, because we don't know basically who has done it, we have to be able to easily transform the matrix in the form where we need it. It is also that in some cases, although you have done it, you may want to change it. So transposing only means that you change the rows and the columns, vice versa. So these properties what you have here, the first two are easy one. If you transpose the matrix A and you transpose it once again, you do the operation twice and you should have the original matrix there. If you want to transpose the addition of two matrices, you easily see that it is the same as adding transposed matrices separately. This one is something which is not easy to see, but what you need to remember that if you have a multiplication and you want to transpose that one, for the result it is easy, but if you want to separate these, you have to transpose both of them separately, but also change the order, because for the multiplication the order is very, very important. So here what we have some examples. All the blue ones here are the ones where you can go and change the value here, like you want to just change it and enter and it is changed here. So it shows you what you do. So if you have just A plus B, corresponding values 1, 1 are added together. 1, 2, 1, 2 is added together, and so on. And for subtraction, exactly the same, but of course there is only the minus sign. So the matrices must have exactly the same size, and the result is exactly the same size. What is missing here is an example of the transpose. So if you would transpose this A here, your first row would be 2, 1, minus 1. Second row would be minus 3, 2, 4. So the corresponding column and the row is just rewritten in the new form. So it also affects the size of the matrix. If it's the square matrix, size is exactly the same, but if it's not, then the size is also vice versa. So for example, I see it here in the introduction. If we transpose this one, we would have 2 rows and 3 columns, and size would be 2 times 3. So there shouldn't be any problems with the exercises till this one. If I find here. So do this. Let's do so that you solve the exercise 1. All these cases, and when you have done that one, you can start with the Mathcad or with the Excel. And whenever you have problems with these cases, just ask. Have you ever solved any matrices with the Excel?
Well, never, to be honest.
Okay, yeah. Probably you didn't notice, but here is the introduction to programs. There is no MATLAB here, but there is the Excel. So you can follow this one. And don't mind about this in Finnish. By far you should already understand the Finnish. What I cannot say too many times, whatever you do, just remember to push Ctrl Shift Enter. Otherwise, it's not working correctly. All what you said here is also said here in English. So if you don't understand the Finnish part. But let's try. And today the idea is that you are familiar with solving matrices with Excel and MATLAB. Excel is already there, and I think MATLAB you can find from virtual desktop, hopefully.
Excuse me, may I ask you something?
Of course.
Yeah, so I wanted to ask about the plus function. So, am I right that the matrices with different like dimensions, or how we call it, cannot be plussed to each other?
Yes.
And the identity matrices always has like dimensions of like equal values, like 3x3, 4x4. It cannot be 3x4, for example, right?
That's what I have understood for the identity matrices. And I said I have understood when we are working with the MATLAB, for some reason there is a possibility to have a 3 times 4 or 4 times 5 kind of identity matrices. But basically I agree with you. When we have the identity matrix, it should be exactly the square one, so the number of rows and columns is exactly the same.
Okay. Because I can share my screen. I have done the first calculations, and yeah, let me show it here. And for the I, which I give here the identity 3, it shows like nothing because the error dimensions do not match.
Yeah.
And that's fine.
Yeah.
Okay.
Yeah.
Thank you.
Now you can do the same with the Excel.
Percent of R square. Like
So,
in this case, when I exclude the years, is 44%.
So show me the first table here. Okay, yes, that's, yeah, and then go down a little bit to go that part. Why would you erase the year?
Because I see the constant is so awkward.
You don't matter that one whether it's awkward or not. what you read is the significance column. If there is a number which is more than 5%, then you think about excluding that variable. And in your case, none of them is more than 5%, so you shouldn't exclude any of them.
Yes.
Mm.
And about the correlation, when I do the statistics,
Mm?
but I see there's just a little uh, word can be right about the tables. So is that okay if it's too short? For example, one chapter like this.
Yeah. But there is a problem in your case, in regression, a big problem. Regression, not correlation. Check your variables. What kind of variables you have there?
It's use elevator.
Yes, but what kind of variables are they?
Uh, I don't remember much.
Mm.
Like, what was the problem?
Because in regression, you can use only numerical variables, not categorical at all, only if they are dummy variables. And I am not sure that all of these are dummy variables. For dummy variables, we only allowed values of 0 and 1.
Yes.
So in my eyes, I see the categorical variables which are not allowed in regression.
So, urban years cannot be in these things, isn't it?
I think year is a numerical one. Year is allowed. But fit your sauna and elevator,
Oh yeah. So the make
the first three, urban, sauna and elevator, check that the only values those variables have is 0 and 1. Otherwise, you are not allowed to use them.
when I checked the urban, they are have value like 1 and 2.
No,
Right.
only 0 and 1. Not even 1 and 2. Only 0 and 1.
Yes. So
Mm.
I will check it again.
Yeah. But if I were you, I would take the more numerical variables because you have them there. So add more about them to your regression, not categorical ones.
Mm, can you repeat it again? Sorry.
You have in the regression, the predictors, they should be numerical variables.
Yes.
And in your case, you have 3 categorical variables, not numerical ones.
Yes.
So change your variables.
Okay. Okay. I will do it. Thank you.
No problem. Actually, I found it, how to change the name. So hopefully you can see my...
Yes.
Can you see the Excel or lots of names?
a lot of names?
Yeah, I thought so. Let's take this one. So now you should see my Excel. So this is my mat A. And if I want to have the one row more, like this one, in formulas there is the name manager. In there I can just edit, and now I say, okay, I just want it to be this part.
Yes.
Now I just manage. and then OK, and it's changed. So if I now take the mat A, it's all of it.
Yes. Okay, thank you.
No problem.
Mm.
Let's continue later. I have a meeting starting, so I have to continue to that one. If I remember correctly, we have the lectures later on this week. Yes, on Friday. So try to get the Excel and MathCAD things done before Friday, so you know how to use them. And on Friday also we go through the multiplication, determinants and the inverse matrices. We also have some time to go through the MATLAB and try to get the MATLAB to your use before that one, because I have it on my computer, but to check that it's also with you, prepare. If you don't get it, send me email ASAP so I can inform the IT that we actually need it right away. All right. See you on Friday.
See you. See you. Thank you.
Bye-bye.
Bye-bye.